What's up, everybody? It's Dan from SageMathTutoring.com and back with another video, this time reviewing some trigonometry concepts that have to do with converting degrees to radians and vice versa, and also finding coterminal angles and finding the sine, cosine, and tangent of various angles without using a calculator. So let's dive in. Looking at number 1A, convert each degree measure to radians, express radians in terms of pi. Okay, so most people probably remember that if you're going to be converting degrees to radians, it would be a matter of multiplying the degree measure times pi over 180. And I like to think of the fact that these sort of degree symbols would, in a sense, cancel, therefore. And as a result, we would have 120 over 180 pi, which is 2 pi over 3. Okay, pretty simple. So it would be the exact same process for all of these. So this would be pi over 180 times that. So that's going to be 225 pi over 180, which is 5 pi over 4. This one would be a matter of multiplying times pi over 180, and that would become 5 pi over 3. And then finally, we would have this one. Pretty easy, right? And that would become 11 pi over 6. Okay, so as you are probably noticing, I am definitely reducing all of these, and the teacher would appreciate that. Okay, so looking at problem number 2A, convert each radian measure to degrees. Use fraction form if necessary. So in this case, it would be a matter of multiplying. If you're going from radians to degrees, you're going to have to multiply everything by 180 over pi in this case. And the way I like to remember it is the fact that now the pi's are going to get canceled. Canceled out. Now, you do need to be careful in the sense that sometimes radian measures won't feature a pi. And in fact, it looks like the teacher is already kind of testing the students on that fact, in that this is literally 6 radians. Most of the time, radian measures would have a pi in it, but not always. So nonetheless, you would still be multiplying this 6 times 180 over pi. So as a result of this, we would have the pi's canceling, and that's going to be 30 times 7, which is 210 degrees. It would be the same deal with this. The pi's would cancel, and next thing you know, you're going to have 45 degrees there. Similarly, we would multiply this one by 180 over pi. The pi's would cancel. Next thing you know, you're going to have 120 degrees. And again, like I said before, you don't really want to be thrown off by this. This would be 6 times 180 over pi, which is 1080 over pi. All right, so that's that one. Looking at 3A, find the sine, cosine, and tangent of each of these angle measures. Okay, so a couple concepts are necessary for this part. The first is that the sine of any angle is going to be opposite over hypotenuse. The cosine of any angle is going to be adjacent over hypotenuse. And the tan of any angle is going to be opposite over adjacent. That's an important concept that you need for these problems. It's also the case that you will need to know that there is this sort of formulation. Some teachers would say all students take calculus. You could also think of it as CAST, C-A-S-T. But this little symbol lets you know which trig functions are positive where. So all 3 trig functions happen to be positive in the first quadrant. Only sine happens to be positive in the second quadrant, therefore cosine and tangent are negative. Only tan happens to be positive in the third quadrant, therefore sine and cosine are negative. And only cosine happens to be positive in the fourth quadrant, therefore sine and tan are negative. So that's an important concept. It's also important that one recognizes that when you're sort of analyzing triangles inside the XY coordinate plane, you're going to want to sort of think of either a triangle positioned in the first quadrant like this, a triangle positioned in the second quadrant like this, the third quadrant like this, and the fourth quadrant like this. And I find it helpful to sort of think of a bow tie. And the angle that you're analyzing will always be this angle that's sort of close to the origin. So if you could remember this formulation and this formulation as well, that would be really helpful. Okay. I'm also going to say that it's necessary to acknowledge that this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees. Okay, so that's something you need to know. Now, another thing you need to know, okay, is that the cardinal points, if we were to have a unit circle here, meaning a circle with radius 1, well, the coordinates of this point here would be 1, 0. The coordinates of this point here would be 0, 1. The coordinates of this point here would, of course, be negative 1, 0. And the coordinates of this point here would be 0, negative 1. So that's going to be important to recognize. And I'm also going to say that when it comes to the unit circle, sine is equal to literally just y, the y coordinate. Cosine is literally equal to just x, and tan is equal to y over x. Okay, so I'm going to say that for these problems, you need to have in your back pocket that piece of information here in this sort of blue border. This piece of information needs to be in your back pocket. This piece of information needs to be understood. Not only the angle measures of the, I call them the cardinal points, 0 degrees, 9 degrees, 180, and 270, but the fact that you're sort of thinking of this bow tie, and when you're analyzing triangles on the XY coordinate plane, it's going to be a triangle that looks like this, 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 or this. And then finally, you need to have an understanding of a unit circle and what's going on at the cardinal points of the unit circle and what the coordinates of the cardinal points are in the unit circle. Okay. Now I know that that's kind of a lot of information, but with practice, you're going to internalize all this. And I hate to say it, but actually there is another concept you need, and that is the fact that it is the case that when you have a 30, 60, 90 triangle, let's say the hypotenuse is 2, well, the short leg would therefore be 1, and the longer leg would be radical 3. So that's important. And you also need to know that if you have a 45, 45, 90 triangle, 45, 45 degrees, and let's say that this is 1 and this is 1, well, the hypotenuse in that case would be radical 2. So that's another piece of information that you're going to need to tackle these problems. So let's look at 3a. So 3a says find the sine, cosine, and tangent of 5 pi over 6. Let's convert that to degrees in order to make things easy for ourselves. The pi's would cancel. 180 divided by 6 is 30. 30 times 5 is 150. So we have 150 degrees. Now, what does that mean? That means that we have a scenario where we have an angle opening 150 degrees. Now, that would land us in the second quadrant. And the reason I know that is because that's 90 degrees. This is 90 degrees, right? And then that's 180. So it's going to be somewhere in between. So we're dealing with this triangle here, right? We're dealing with a triangle that kind of looks like that. And seeing as how it opens to 150, well, it makes sense that this little guy is going to be 30 degrees because 150 plus the blue 30 is going to give us that full 180. Now, ultimately, they want the sine, cosine, and tangent, so we'll sort of set that up. It's ultimately going to be sine of 30, to be honest. Cosine of 30 and the tangent of 30, because it turns out that's just going to be the same. So with regards to the sine of 30, well, according to this structure here, when you have a 30-degree angle, the side length that's across from the 30 is 1, so long as we're treating the hypotenuse as 2. So we have 1, 2, and then we have a radical 3 right there. So sine of that would be 1/2. Cosine would be, let's see, adjacent over hypotenuse. So that's going to be radical 3 over 2. And the tangent is going to be opposite over adjacent, and that's 1 over radical 3. Now, my student who's watching knows that that turns into radical 3 over 3 after rationalizing the denominator. Let's also take into account the fact that we have all students take calculus, which means the only one that's positive in the second quadrant is sine, so therefore we can put a negative in front of the cosine and tangent. So that's all there is to it. Now, it is the case that I did say sine of 30, cosine of 30, tan of 30, but I really could have said sine of 150, cosine of 150, tan of 150. It all ends up being the same thing, so long as you use this method, okay? I'm going to do that from here on out. From here on out, I'm going to say sine of the angle, cosine of the angle, tan of the angle, whatever angle we're analyzing. So looking at 3b, let's convert that to degrees. We're looking at 180 over pi. We have the pi's getting canceled, and that's going to be equal to 225, okay? So which quadrant are we in that case? Well, we would be in down here, right? We would be down here. So therefore, we're looking at this part of the bow tie, this triangle in the bow tie. So we have a triangle here, and 225 minus 180 is 45. So that means that this angle right here is going to be 45 degrees. So clearly we are dealing with the 45, 45, 90 scenario. So let's go ahead and label this one. We'll label this one, and we'll label this radical 2. So therefore, we're looking at, I'll say, sine of 225. We're going to be analyzing that. We're going to be analyzing cosine of 225 and tangent of 225. Okay, so the sine of 225 would be opposite over hypotenuse. Now that's going to be 1 over radical 2, aka radical 2 over 2. Cosine would be the same thing, radical 2 over 2. And the tan would be opposite over adjacent, which is 1 over 1, also known as 1. Okay, now we're not done yet. You got to be careful. All students take calculus. So the only one that's positive is tan, which means the sine gets negative and the cosine is negative. Okay, looking at part C. So 2 pi, if we were to convert that, if we did, 180 over pi, well, of course, the pi's would cancel. Next thing you know, you have 2 times 180, which is 360 degrees. So that means that, we would have an angle that literally, starts here, but then goes all the way around and then lands right there. Now, I really should have said that this is 0 or 360, right? Now, this is where this concept would come into play. You're going to want to imagine that there's a unit circle drawn here, and this kind of weird so-called angle, because we don't really have any triangles that we could draw. We can't draw a triangle that looks like this, or this, because we kind of landed right on the x-axis. So that's like a special situation. Anytime you land on the cardinal points like that, that means you got to rely on this concept here. Now, remember, sine, when it comes to the unit circle, which is this concept, I'll do a little asterisk to remind us of that. Okay, Whenever you're dealing with sine, it's just the y coordinate. Whenever you're dealing with cosine, it's just the x coordinate. Whenever you're dealing with tan, it's just the y over x. So in the case of sine of 360, it's going to be something. Cosine of 360, it's going to be something. And tan of 360, it's going to be something. Now, as far as the sine of 360, that's going to be the y coordinate. Well, what's the y coordinate here? Well, that's clearly 0. When it comes to the cosine of 360, well, cosine is clearly the x coordinate, so the x coordinate is 1, so that's going to be 1. And when it comes to the tan of 360, tan is y over x, so that's going to be 0 over 1. You do have to be careful with that. 0 over 1, which is just 0. Okay, so that's that one. Looking at part D, if we were to convert that to degrees, we would have this scenario. Pi's would cancel. You would have 60 times 5, which is 300 degrees. Now, that would, in the xy coordinate plane, that would land us in the 4th quadrant, which means we would be dealing with some kind of a triangle that kind of looks like this one, right? So you could always draw that. Now, if that's 300 degrees, well, that means that this angle measure must, of course, be 60 degrees, which means we are dealing with the 30, 60, 90 triangle, only now across from the 60 degrees is radical 3. So we can definitely label that. Across from the 30 degrees is going to be the 1. So we can label that. And then the hypotenuse itself, we're going to call 2. Okay. Now that triangle is not drawn to scale, but let's just go with it. So let's set things up. Sine of 300 is going to be something. Cosine of 300 is going to be something. And tan of 300 is going to be something. So the sine is going to be the opposite over the hypotenuse. So the sine of 300 is going to be radical 3 over 2. Radical 3 over 2. The cosine is going to be adjacent over hypotenuse. So that's going to be 1 over 2. And the tan of 300 is going to be opposite over adjacent. So that's going to be radical 3 over 1, also known as radical 3. All right. So please do keep in mind that these are the concepts that you will need for these problems. Okay, so for these problems, you definitely need the all students take calculus format. You also need the Pythagorean theorem, that a squared plus b squared equals c squared, okay? And you will need to understand that sort of bow tie configuration as well, okay? So these are the important concepts that you will need for these problems. Now, looking at 11, it says sine of theta is 4 over 7, and the terminal side is in the 2nd quadrant. And they want us to find the sine, cosine, and tangent of that angle. Now, if it's in the 2nd quadrant, that means we're dealing with a triangle that looks kind of like that. So we would be dealing with a triangle like that. And since the sine of that angle is 4 over 7, that means the opposite, the angle would be here, by the way. That means it's opposite over hypotenuse, so that means we're looking at 4 over 7. Now, in order to figure out the sine, cosine, and tangent, you're going to need the other side length, right? And that's where the Pythagorean theorem would come into play. It would be 4 squared, let's call this b. 4 squared plus b squared equals 7 squared. That's going to be 16 plus b squared equals 49. And that's going to be b squared minus equals 49 minus 16. 9 minus 6 is 3. 4 minus 1 is 3. So b is going to be radical 33. Now, I'm going to say that once you get that, you should go ahead and label once you get that. Okay. So the sine, cosine, and tan is going to be very easy. All right. Let's set this up. Well, the sine we already have, obviously. The sine is 4 over 7. The cosine in this case is going to be adjacent over hypotenuse, so that's going to be radical 33 over 7, and the tan in this case is going to be opposite over adjacent, also known as 4 over radical 33, also known as 4 radical 33 over 33. Now you're not done yet because you do need to take into account the signs. All students take calculus. When it comes to the second quadrant, the only positive trig function would be sine, so therefore this cosine gets a negative and this tan gets a negative. All right, so that's that one. Okay, so that is how that one would work. Let's keep this structure, but we'll get rid of everything else. Okay, so looking at problem number 12, cosine of theta is 5 over 13. The terminal side's in the fourth quadrant. Okay, no problem. So we are dealing, of course, according to the bow tie, with a triangle that kind of looks like that. We already know that cosine is adjacent over hypotenuse, so clearly the adjacent must be 5. The hypotenuse must be 3. Now, this is a special right triangle. I happen to know the other side is 12, but let's say you had forgotten that. It would be the case that you could call that b. You could say 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169, b squared equals 144, and b therefore equals 12. So that would be true in that case. So the sine of whatever this theta is right there would be 12 over 13, opposite over hypotenuse. Cosine is already given, that's 5 over 13. The tangent would be opposite over adjacent, so that's 12 over 5. Okay, we're not done yet because we need to take into account the signs. It is the case that in the fourth quadrant, the only positive trig function is cosine, so therefore that gets a negative, that gets a negative. All right, so that's how you do that one. All right, looking at problem number 13, the tan of theta is 4 over 3. The terminal side is in the fourth quadrant, so of course we'd be, or third quadrant, I should say, so we'd be dealing with a triangle that kind of looks like that. So we're looking at this, we have a theta, and tan is opposite over adjacent, so that would be 4 over 3. Using the Pythagorean theorem to find, we'll call that C. That's also a special right triangle. I happen to know that that's 5, but let's use the Pythagorean theorem. It would be 4 squared plus 3 squared equals C squared. That would be 16 plus 9 equals C squared. 25 equals C squared, and therefore C equals 5. So let me just go ahead and erase that, and we're going to replace it with a 5. Now we're ready to go. The sine of theta is opposite over hypotenuse, so that's going to be 4 over 5. The cosine of theta is going to be adjacent over hypotenuse, so that's going to be 3 over 5. The tangent is going to be opposite over adjacent, so that's going to be 4 over 3, and that was given. Considering the signs, according to our structure here, only tan is positive in the third quadrant, so therefore we put a negative in front of that, and we put a negative in front of that. So that's how you do that one. All right, looking at problem number 14. We are in the second quadrant. It does say the tan is negative 5 over 7. Okay, interesting. So it looks like they're already taking the sign into account, at least when it comes to tan. So let's take a look. If it's in the second quadrant, it would be a triangle that looks like this. And let's go ahead and just draw that real quick. And it's the case that it's negative 5 over 7. So that means it's opposite over adjacent. So we're looking at 5 here and a 7 here. Now, in reality, it's really positive 5 over negative 7, which turns out to be the same as negative 5 over 7. You can kind of think of it that way. So nonetheless, if we were to use the Pythagorean theorem, we're looking at 5 squared plus 7 squared equals C squared, and that's 25 plus 49 equals C squared. Therefore, C squared equals, looks like that would be 74. So C is equal to radical 74. So we could write that right here. Let me just double check. So yes, that should be correct. So at that point, the sine of theta, this theta in this case, would be opposite over hypotenuse, which would be 5 over radical 74, also known as 5 radical 74 over 74 after rationalizing the denominator. The cosine would be adjacent over hypotenuse, so that would be 7 over radical 74. Let's kind of blow this up a little bit. And that would be, after rationalizing the denominator, 7 radical 74 all over 74. And the tan we already have, that happens to be, they made it clear that it's negative 5 over 7. Cool. Now, let us take into account the signs of each quadrant. In the second quadrant, only the sign is positive. So therefore, this cosine is also going to get a negative. We have a negative associated with the tan, and we have a negative associated with the cosine. So that's how you do that one. Okay, looking at problem number 15, it's cosine of theta equals 3 over 7, and we're looking at the first quadrant, so that would be something that looks sort of like that. So let's draw a triangle that looks like that, and it's the case that it's cosine of theta equals 3 over 7. Now cosine is adjacent over hypotenuse. So we're looking at 3 here and a 7 there. Pythagorean theorem, let's call this b. Pythagorean theorem would say 3 squared plus b squared equals 7 squared. 9 plus b squared equals 7 squared. And, well, I should say 49 to be honest. So let's just say 49. And b squared equals 40, and therefore b equals radical 40, aka 2 radical 10. So I'll just kind of draw that here. So the cosine is 3/7. We could write that right away. The sine is opposite over hypotenuse, so that would be 2 radical 10 over 7. And the tangent would be opposite over adjacent, so that's 2 radical 10 over 3. Now, investigating the positive and negative signs, apparently all the trig functions are positive in the first quadrant, so we're fine here. Okay, looking at these problems, find all the angles between 0 and 360 with the given property. So I think it would certainly be good to remember all students take calculus for this. That's for sure. It would also be the case that we should remind ourselves of the fact that we're dealing with triangles that would look, like that, depending on which quadrant they're in. And that's really, I think, all we sort of need to know. So when it comes to problem number 16, the sine of theta happens to be a positive number. So therefore, we know that the triangle that we're going to notice is going to be in the first quadrant because all trig functions are positive in the first quadrant, and sine and only sine is positive in the second quadrant, whereas sine would be negative down here and sine would be negative down here. So we're looking at a scenario where we're only sort of analyzing these two triangles, okay? Now, this tells you opposites over hypotenuse. Now, what I'm going to strongly suggest is to sort of imagine that there's this 1 underneath. And it is the case that sine of theta is opposite over hypotenuse. So therefore, the so-called hypotenuse in this case, we're just going to call that 1 always. So this is 1. And the opposite side is this one, 0.4593. right? And therefore, this one would be 1, and this would be 0.4593 right there as well. So we're really looking for, we could say, this angle right here, and we're also looking for something kind of interesting. We're also looking for not just this angle theta, but we're also looking for another angle, and that would be the angle that you would get by opening all the way here. Okay, so what we're going to do is we're going to go on a mission, though, to find this green angle first. And the way that you could do that is you could say, okay, well, the sine of whatever that angle is equal to this. So it is therefore the case that the inverse sine of 0.4593, well, that's going to equal that sort of green theta there. Now, you do need a calculator for this. It is the case that the inverse sine of 0.4593 is 27.3 degrees. So that means this is 27.3 degrees. So then the question is, okay, well, if the green one is 27.3 degrees, what's this yellow one? Well, hopefully my student who's watching this knows that this 27.3 degrees could be here. We could say that it's here, but it's also here, right? Isn't it right there? 27.3 degrees as well. This angle right there. So I think my student recognizes that if we want this yellow angle, well, that would be 180 degrees minus this green angle, right? That would be 180 degrees minus 27.3. So 180 minus 27.3 is 152.7. Okay, so that would also be the other answer. So the first answer is that 27.3 would be an angle such that the sine of the angle is 0.4593, and it would be the case that 152.7, this yellow angle, would also be an angle such that sine of that angle equals 0.4593. Okay, so hopefully that makes sense. Okay, moving on to the next one. The cosine is negative 0.6432. Well, we know cosine is negative here and here. It's positive here, and all trig functions are positive here. So cosine is negative here and here. So I'm going to say let's go ahead and just draw this sort of triangles that would be associated with that. And they're saying, okay, the cosine of theta is that. So therefore, of course, without even really analyzing this too much, let's just kind of go to the calculator right away, to be honest. So I think my student by now is recognizing that you could use the inverse cosine of negative 0.6432, and then you're going to get at least one of the angles. You're going to get either this angle right here, or you're going to get the angle that starts here and goes all the way here. It's going to be one of those two, but it's probably going to be this one. Okay. So when I plug that into my calculator, I get 130, basically 130. Okay. So what that means is that would be one of the sort of angles. It's 130 degrees. But then the question is, well, how are you going to find, like, if that's 130 degrees, well, how are you going to find the other angle? How are you going to find this green angle that starts at, that starting point and then ends up here, right? How are we going to find that green one? Well, once again, my student's pretty good at this, I noticed. It is a matter of recognizing that, if that blue angle is 130, well, clearly this angle right here needs to be 50 degrees because the blue 130 plus the red 50 degrees would be a total of 180 degrees, and therefore it is the case that there'd be another 50 degrees right there, right? Another 50 degrees right there. So it would be starting here, going up and around, you hit 180, and then it's going to be an extra 50 in that direction. And 180 plus 50 is 230. So we're looking at 230 as the other angle. All right, so that is how you do that one. Hopefully you're recognizing how helpful it is to actually draw this situation. Okay, so that's that. Get rid of this, looking at the next one. Problem number 18, the tangent is positive. Now we know that it's positive in the first quadrant and the third quadrant, so if it's a positive tangent, we are most definitely looking at this one or looking at this one. And let's go ahead and plug the inverse tan of 1.345 in our calculator, and we will get 53.4. Okay, 53.4. It's obvious, hopefully to everybody, that that 53.4 is, say, this angle right here. As we start here, we end up there, and it's 53.4 degrees. So it stands to reason, therefore, that this would also be 53.4 degrees. So one of the answers is 53.4, right? That's one of the answers right here. And then if we want this other angle, the angle, in other words, that starts here, goes up and around all the way, and then eventually it hits this thing. I think my student recognizes that that's going to be 180 plus another 53.4, and that is 233.4. So the other angle is 233.4. So that is the other answer. Okay, continuing on. Let's see. We've got the sine of theta equals 1.234. And sine is positive here. Sine is positive here. We already did a problem like that in the beginning. So therefore, of course, we are looking at either this triangle or this triangle. And let's go ahead and use our calculator. Inverse sine of 1.234. I think this might be undefined, but let me just double check. And that equals theta. So when I plug that into the calculator, I get undefined. It's kind of beyond the scope of the lesson that my student is in the middle of, but sine and cosine of an angle can only be between -1 and 1 inclusive. Now this is greater than 1, so that's a problem. Okay, so the side of an angle cannot be greater than 1, and this is greater than 1. So therefore it's undefined. So I guess your teacher or my student's teacher is just throwing one of those in there just to test that. This should work because the cosine of an angle has to be between -1 and 1. Well, it's the case that this is certainly within that range there. So it's positive, and we know that cosine is positive here. We know that cosine is positive there. So let's go ahead and draw those triangles. And let's go ahead and plug in the inverse cosine of 0.2501. And we know that that's going to be equal to some angle, and that is equal to 75.5. Okay, now clearly that's angle, right? That's 75.5. Now what that means is that we're going 75.5 down in this direction as well, right? So that would be, you know, in the case of this, it would be 360 minus that, right? Because the first angle is right here, and the second angle that we're trying to figure out is the angle that starts here and then goes all the way around and ends up there. And I think my student recognizes that that would be a matter of a full revolution, which is 360 minus that 75.5. So 360 minus 75.5 is 284.5 degrees. So those are the two answers for that one. Okay, so looking at this one right here, the tangent of theta happens to be negative. Now we know that the tangent is negative in this quadrant and this quadrant, so we could always draw those two triangles, okay, in accordance with the bow tie situation, right? You have a triangle that looks like that in the second quadrant, and you have a triangle that looks like that in the fourth quadrant, right? Using our calculator, we have the inverse of tan of negative 4.3331, and that's going to equal some angle, and that happens to equal negative 77. We'll just call it that, negative 77. Okay, now that's kind of an interesting one, because what that essentially is saying, that's essentially saying this is negative, because when it's negative, when the angle is negative, we're going in the clockwise direction. So it's kind of a funny thing. That it would give us that negative 77. So that's actually interesting. So the calculator produced a negative angle, but the problem is that they want all the angles between 0 and 360. They don't want negative angles here, right? So what we're going to have to do is we're going to have to ask ourselves, what's sort of the positive version of this negative 77? Well, that would be the angle that goes all the way around and then hits that thing, right? And that is going to be 360 minus 77. Okay, 360 minus 77, and that happens to be 283. Okay, so I'm going to say that's one of the answers. That's this big blue one, right? But now, of course, we want this yellow one. We want this one that starts here and then ends right there, right? Well, we do have a clue as to what that might be, because we know that this angle is, we could say 77 degrees, right? That's 77 degrees. So this yellow angle that starts here and then ends here, well, that's going to be 180 minus 77, right? So 180 minus 77 is 180 minus 77 is 103 degrees. So let's go ahead and write that as our other answer. Okay, 103 degrees. Okay, so these are the two answers for problem number 21. Okay, now we're looking at sine of theta equals negative whatever, and it's negative, and we know that sine is negative in this quadrant and this quadrant. How do I know that? Because all trig functions are positive here, sine is positive here, and therefore we're looking at quadrant 3 and quadrant 4. So we're going to go ahead and draw our triangles there, and let's go ahead and get to it. We have inverse of sine of negative 0.3899, and in my calculator that becomes, we have negative 22.9 degrees. Now once again, we're being given a negative angle, which means that it's communicating to us that we would be going down 22.9 degrees there, 22.9 degrees. However, we want, according to the directions, we want angles between 0 and 360. So we're going to have to figure out, they call it coterminal angles. We're going to have to figure out coterminal angles. So let's start with this one. So it's going to be such that it's starting there and then it goes all the way, and then we go to here. So it would be, of course, a matter of considering a full revolution of 360 degrees and then subtracting 22.9 from that. So 360 minus 22.9 is 337.1. 337.1 degrees. So that's this large angle that goes all the way around to that moment right there. So we would have theta equals 337, pardon me, 0.1 degrees. Okay, now of course we're not done. We need to find this blue angle that starts here and then goes all the way to there. Well, the good news is we know that this angle right here is most definitely 22.9 from our previous exploration, right? So this, of course, would be this larger blue angle would be a matter of 180 plus that additional 22.9. So 180 plus 22.9 happens to be 202.9 degrees. So these would be your answers for that last one. Okay, this one here. So hopefully that all makes sense. It's one thing to watch a video like this and understand it and have the light bulbs go off and all that good stuff, but it's a whole other thing to practice this stuff. So without practicing, I will say for sure that you're not going to remember how to do any of this. So that's just a fact. So definitely encourage you to practice for sure. If you have any questions, please comment below. And if I made any mistakes, as per usual, just comment, let me know below. But nonetheless, despite any potential careless mistakes, the process itself is absolutely correct, and that is the way to answer all of these questions. So hopefully this was helpful, and I will see you all later. Take it easy. Bye.